What's up, guys? It's Mr. Bringle. And today we're going to be talking about the concept builder for position versus time graphs. That is specifically, and I'm going to circle this here, the numerical analysis assignment. There's another one that is conceptual analysis, so please make sure that you're on the correct one. Also, make sure that your email is showing for the student name. If it says guest, then it is not going to save your progress. So this has to do, obviously, with position versus time graphs. And this first trophy is all about the difference between distance and displacement using the position versus time graph. So we need to be real careful whether it says distance or displacement so that we know if we need to use positive or negative signs. So let's go ahead and start here. And this one is asking us to determine the distance that the object moved in meters during the 20 seconds of motion. So distance is simply, another way to say that would be the path length. So the length of the path that was traveled. You kind of want to split this up into two legs here. So the first leg is 5 seconds up to this point. So we need to see how far did the object travel from here to here, and then how far from there to there, and then we will add those together, okay, for distance. Now, that would be different for displacement because we would just be interested in the final position minus the initial. So anyway, this object starts at 7 meters, and then after 5 seconds, it ends up at 17 meters, okay, and then it moves back to 5 meters right here. Okay, so during this is positive 10 right here. Okay, and then I guess you don't have to put the positive on there because we're just going to be adding these together. And then it does go backwards 12 meters here, but again, the direction does not matter when we're doing distance. So we're literally going to add these two together. It's going to be 10 meters plus 12 meters, and we know that is going to give us 22 meters of distance. Okay, go ahead and clear the screen. Okay, so now this one says use the graph to determine the displacement. So that's key, displacement in meters of the object during 20 seconds of motion, and then use the appropriate positive or negative sign. So for this one, as I mentioned before, we're interested in the final position and the initial position. The initial position is right here at 10 meters, and the final position is up here at 20 meters. The fact that the object was going backwards here and then starts moving forward again has nothing, it does not matter. All we care about is that final position and the initial position, because displacement, or the change in position of an object, is simply the final position minus the initial position of the object, okay? In this case, that is going to be 20 meters minus 10 meters, which is simply 10 meters of displacement and positive 10 meters. Whoops. Positive 10 meters, okay? So this should be positive 10. Okay, good. So we'll go ahead and clear the screen. Go back here. This one is asking us to determine the displacement again. Okay, so displacement during 10 seconds of motion. Okay, so once again, all we have to do is mark the initial position, which is 1 meter, and the final position, which is 10 meters. Obviously, it's a positive 9 meter displacement, but just remember that displacement or change in position is the final position minus the initial position. So that's going to be 10 minus 1. It's just going to give us positive 9 meters. Okay. Just wanting to go through the equation in the math there, because it's not always going to be as simple as 10 minus 1, I guess is what I'm getting at there. Go ahead and leave that equation there just in case. And we've done a good job. Nailed it. All right, let's keep moving. So on this one, it says to determine, once again, the overall displacement of the object during 20 seconds of motion. So again, we will mark the initial position, which is 5 meters. and the final position here, which is 10 meters. So obviously this is going to give us a positive 5 meter displacement. Uh-oh. It looks like, there we go. Okay, so it froze on me for a second, but I just had to press escape to get out of the full screen. So that was the end of the first trophy. On the next one, it's focused on speed and velocity. So we'll go ahead and get back into this and go back to full screen here. But for this, we have to determine. This says determine the velocity of the object, enter the appropriate positive or negative sign. So remember that speed uses distance. There's no direction with either of those. And then velocity uses displacement. So there is direction with both of those things. So we do need to say if it's moving at positive or negative 5 meters per second. Lights just went out on me in the classroom. So this is, there's a couple ways that you can do this. You can pick 2 points and calculate the slope. You can try to eyeball it. I would be careful about that because sometimes it's kind of hard to tell exactly where the line is. But I'm going to go ahead and pick 2 points on this graph. This looks like a nice point right here that's right on 2 lines for me. And then this is 0, 0, which obviously makes it easy. So we've got 0, 0 here. And then this one would be 1.2468. So 1.2 is our x-axis. So this is going up by 0.2s, each one of these here. Okay, so 1.2. And then that's at 2 meters on the y-axis. Okay, so for slope, remember that it's y2 minus y1 over x2 minus x1. Now, specifically for this graph, when we say y2, we're talking about the y-axis. Well, that would be your final position minus your initial position, right? Y2 is final position minus initial position over the final time minus the initial time, okay? So this is going to be 2 minus 0 meters, so the final position. And I know that this right here, so since we put x down here, right, and then there's also x here, remember this is position, and this is talking about the x-axis. I apologize for my handwriting. I'm in an awkward position here. Okay, so 2 meters over, this is going to end up being 1.2 minus 0 seconds. So it ends up being just 2 over 1.2. Now I'm going to have to pull the calculator out for this. A lot of these, they make them easy and it's 1 or 2 meters per second, but this one not so much. So this ends up being 1.6 repeating. So like 1.67 meters per second, and it would need a positive sign. Okay, so let's try that out here. So positive 1.67. I don't know how it's going to want us to round. Hopefully that's right. Great. Okay, now, so this one I want to talk about conceptually for a second because this is a negative slope. And the most common misconception is that this means that the object is slowing down, and that is not true. The object is not slowing down, and I know that because the slope of this line never changes. Remember, the slope of the line tells us the velocity or the speed of the object, okay? So if that slope doesn't change, if that angle is not changing, right? Like at one point it starts at a, it goes to a different slope like this, or maybe it flattens out and goes horizontal. Like if it did something like that, then that would be a change in slope. But this does not change its slope, which means the velocity doesn't change the whole time. So all this is showing us is that the object is actually just moving backwards, right? So it starts at 15 meters and then it ends at 5 meters. So it's just moving backwards, okay? So what we want to do here is, again, calculate the slope. And let's just pick these 2 points because these are easy, the beginning and the end here. And so this would be 5, 5. And this one here would be 0, 15. Okay. So we'll go back to our slope calculation, which is y2 minus y1 over x2 minus x1. And again, remember that this is going to be your change in position, the final minus the initial, over the change in time. So last time I actually wrote out xf minus xi over tf minus ti. Just want you to see it a different way. Change in position over change in time. That is the equation for velocity. So our change in position here, our final position is 5 meters minus the initial, which is 15 meters. Okay, so we have a negative 10 meter displacement. And then we know that this took 5 seconds, obviously 5 minus 0 seconds. So negative 10 meters over 5 seconds. That's going to give us negative 2 meters per second velocity. Okay. Now, we could have eyeballed this and we could have gone, okay, well, after 1 second, this object went down 2 meters, right? So you can kind of eyeball that and you can see that. So that's another way to do it, but just be careful because, like I said, it can be a little off sometimes. So let's go ahead and just do one more with the negative slope here. And once again, I think this one you can actually eyeball pretty well. So let's do it that way this time. So I'm looking from 0 to 1 second here. So I'm looking up right here. This is 1 second, and it's down here on the y-axis. So right there, that looks like it's gone down by 1 to 3 meters after 1 second. So that means we have negative 3 meters over 1 second. That is going to give us a negative 3 meter per second velocity. Okay. Now, if we had gone through the whole process of calculating the slope again, it would give us the same thing. So we'll check our answer there and we get it correct, which is great. Since that one went quick, let's go ahead and do this last one here. So now we're back to a positive displacement, and this one, I'm sitting here trying to find a good spot to calculate the slope, and this point over here is weird to me. It doesn't look like it's exactly at 10 meters in 5 seconds. And so I'm hesitant to use that. I'm sure it's fine, but for whatever reason, I'm going to make this probably more complicated than it needs to be. This right here, this point looks like it's right on that line. And I know that's weird because this would be 1.2, 1.4, 1.6, 1.8. So this point here would be 1.2, and it's gone up to 4. And then this point here would be 0, 2. So we'll do our slope calculation, which, remember, is going to be the change in position over the change in time. Okay, and that is the velocity of the object. So the change in position, the final position was 4 meters minus the initial position, which is 2 meters, over the time interval, which was the final time was 1.2 seconds minus 0. And so this is going to give us 2 meters, positive 2 meter displacement over 1.2 seconds. So let's go ahead and just throw that in the calculator real quick. And once again, it's given us the, I don't know why I didn't recognize that calculation again, but this is positive 1.67. It's 1.6 repeating, and that did work the last time when we rounded. So it does look like it has frozen again on the full screen. So after that, this happened after I finished the level. There we go. Okay, so you're going to do those 2 levels there, Apprentice and Master, and that will be it. Obviously, if you have questions, make sure to let me know, and good luck.